Okay, let's look at classroom example 3. We're working on applications that actually become quadratic equations that get solved. So here we have the length of a rectangle is 5 feet more than its width. So there's my rectangle, and here's my width, and the length is 5 feet more, or that's addition. 5 feet more than the width. Here's the length, here's the width. The area of the rectangle is 176 square feet. Find the length and the width. Well, area of a rectangle is length times width. So for this rectangle, the area is going to be 5 plus W times W. So this is going to be 5W plus W squared. And we're told the area of this rectangle equals 176. So I'm going to turn this kind of around so that we lead with the second degree term. We've got W squared plus 5W equals 176. And of course, for these quadratics, the first thing is they have to be set equal to 0. We're going to subtract 176 from both sides. Equals 0. So this has to be factored. So on the side here, negative 176, two numbers multiplied together that give me negative 176, that added together give me a positive 5. So they're going to be opposite signs, and the larger number is going to be positive. So 176 and negative 1, nope. So we're going to try negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. Okay, so that's 22 and negative 8. There were some others in there, but you know what? Those don't add up to 5, but I'm getting closer. Negative 9, negative 10, negative 11. Here we go, 16 and negative 11. Multiplied together give me negative 176, but added together give me 5. So I'm going to replace my middle term with what it's equal to. 16W minus 11W. And now I've got a 4-term polynomial. Let's factor out a W here, and we're going to get a W plus 16. I really want a W plus 16 over here, which I will get if I factor out a negative 11. Check and make sure. Negative 11 times W is negative 11W. Negative 11 times positive 16 is negative 176. So what are my two factors? W plus 16, W minus 11. I'll write that up here. So either W plus 16 equals 0 or W minus 11 equals 0. Now I have factors set equal to 0, so we're going to solve them separately. Subtract 16 from both sides, and here I have a width of negative 16. Would it make sense for the length of a rectangle to be negative? No, we're going to disregard that answer. It doesn't make sense for an application problem. Just like time shouldn't be negative, side length shouldn't be negative. But on the other factor, we're going to add 11 to both sides. And so 11 works 11 feet. So if the width is 11 feet, what is 5 plus 11? The width is going to be 16 feet. So my length is 16 feet, and my width is 11 feet. And 11 times 16 is 176, so that's my answer. All right, moving on to classroom example 4. These are all just different types of applications that get solved using quadratics. All right, find two consecutive odd integers. Here's the first one, and here's the second one. If you remember us setting up these placeholders. The first is x, and because of that little word odd, the second odd integer is plus 2. The first one plus 2. Find two consecutive odd integers whose product is when you multiply, x times x plus 2, whose product is, there's my equal, 23 more than 23 plus their sum. So we're going to add x plus 2. Their product, which is when you multiply them, is 23 more than when you add them. All right, so let's distribute the x, and we get x squared plus 2x is going to equal, let's combine like terms here, 23 plus 2 is 25, and x plus x is 2x. Now let's get everything on one side of the equal sign. So let's subtract 25 from both sides. X squared plus 2x minus 25 is going to equal 2x. All right, let's subtract 2x from both sides. That's actually going to cancel. So I have x squared minus 25 is going to equal 0. This is the difference of squares. So my two factors are x plus 5 and x minus 5, which means either x plus 5 equals 0 or x minus 5 equals 0. So either x is negative 5 or x is positive 5. Now I'm not done because we wanted two consecutive integers. So the first scenario is where x is negative 5, so then the second number would be negative 5 plus 2, which would be negative 3. Negative 5 and negative 3, that's one solution. Here's my other possible solution. That's where 5 is my first odd integer, so the second one would be 5 plus 2, which would be 7. That's 5 and 7. So you're going to want to try practice 4. And the thing here is that there are two different scenarios.